Hello again, statistics and pre-calculus. This is a recording for April 2nd. The new topic, dilations of that parent function of the reciprocal parent function. Dilations of the graph of y equals 1 over x. Here's the graph of y equals a over x, with a currently 1. So it has the key point that you know, 1, 1, and negative 1, negative 1. What's interesting about this, it's also got the graph of y equals x, so that you can watch the symmetry go on. If we go to y equals, say, 3 over x, we get the point 1, 3 and the point 3, 1. Y equals 6 over x, you get more points. You move further out, 7.5 over 1 and 1 over 7.5. The graph moves further out, but it does it in a symmetric way so that you have the same point two different places, 1, 5 and 5, 1, which makes sense if you think about the equation as y times x equals a. So 1 times 5 is 5, and 5 times 1 is also 5. There you go. Another nice thing about this, suppose we have 6. There are other pairs of points that multiply to 6. 2 and 3, for example, and indeed, the point 2, 3 is on the graph. 3 and 2 is also on the graph. So you have 3, 2, 2, 3. You have some good points there. Let's take a look at it and get it more specific. Here we're looking at y equals 3 over x. Y equals 1 over x is graphed in gray. Y equals 3 over x. We'll take a look at it. So 3 over x, the point that was 1, 1, now becomes 1, 3 and 3, 1. The point that was negative 1, negative 1 is now negative 3, negative 1, and negative 1, negative 3. Goes both ways, and the graph just moves out a little bit. You notice that the graph still has asymptotes of the x-axis and the y-axis. It also still has the domain x is not 0, and the range y is not 0. What about y equals 12 over x? Well, so what happens? What multiplies? It's easy to think of this as the equation x times y equals 12. What multiplies to 12? Well, 1 and 12 multiplies to 12. That's not quite on the graph, but we can get close to it. 2 and 6 multiplies to 12. 2 and 6. 3 and 4. 4 and 3. 6 and 2. 5 does not go nicely into 12, but 6 does. 6 and 2. And the next number that goes nicely into 12 is 12. So 12 and 1. Out here. We have the lovely branch here. And we also have the negatives of all of those points. Negative 12, negative 1, negative 6, negative 2, negative 4, negative 3, negative 3, negative 4. Also things that multiply to 12, because if you multiply a negative by a negative, you still get a positive. So we have all of these points again. And once again, asymptotes, x-axis and y-axis, domain, x is not equal to 0, range, y is not equal to 0. Very cool. What about if we're looking at y equals negative 5 over x? Get a little trickier. You're multiplying the x's and the y's by negative 5, so the point that was 1, 1 on the parent function is 1, negative 5, and negative 1, positive 5. Positive 5, negative 1, negative 5, positive 1. And again, it might be helpful to think of this as x times y equals negative 5 if you multiply both sides of the equation by x. X times y is negative 5. What pairs are those? Negative 1 and negative, positive 1 and negative 5, negative 1 and positive 5, positive 5 and negative 1, negative 5 and positive 1. So what does it look like? 1, negative 5 is here. Negative 1 and 5 is here. 5, negative 1 is here, and negative 5, positive 1 is there. So this graph, actually, when you when you make it a negative value, it shows you the reflection, and it reflects over. You could think of it as reflecting over the x-axis. This branch goes down here, or you could think of it as reflecting over the y-axis. Either way is totally legitimate, and again, that's because of the symmetry. Domain, no surprise. X is not equal 0. Range, y is not equal to 0. There we go. Last step. What about if you have a graph and you want to know the equation? Well, we can think of it as y equals a over x, but yet again, this is going to be simpler if you write it as x times y equals a. What do we have? Pick a point. We'll pick -4, 2. -4 times 2 is -8. Let's pick a different point. How about 8, -1? 8 times -1 is -8. No surprise, everything's multiplying to -8. So a is -8, and we have the equation y equals -8 over x. You could go to Desmos or someplace like that to verify that that's the equation. It all works. Try it out, see what you've got, make it happen. It'll all be good.